it says to find the blank. So we're just going to say x-intercepts. Also known as zeros or roots or solutions as well. We've talked about it being called solutions. You must solve the quadratic. What we're dealing with in this next unit a lot is solving the quadratic. We're going to find different ways to find the x-intercepts. If you can factor, you know how to find the x-intercepts because that's what we did today. But there's lots of different ways that we can find the x-intercepts for things that don't factor. Okay? So that's what that's talking about, x-intercepts. So next is domain and range. Domain and range has to do with when you're looking at the graph, it's kind of like how far left and right does the graph go and how far up and down does the graph go. Okay? Are there places in the graph where it stops? Are there places where maybe it keeps going up forever but it stops? That's what domain and range is talking about. So here's how they describe it. Domain is all the inputs, or it's the x values of a function. It's how far left and right it goes. So with the graph, you start on the left, and then you go to the right, and you see how far left and right it goes if it asks for domain. Okay? The range is the y values, and it has to do with going up and down. So domain is left and right. Think about the x-axis. Range is up and down. Think about the y-axis. Another important thing that you need to know is about increasing and decreasing. When we're trying to figure out if a graph is increasing or decreasing, you start on the left of the graph and then you go towards the right. Okay? So when you're looking at a graph, like if I was looking at a line that started down here and went up, okay, that would be increasing because you start on the left and then you go up. If I did a line that started way up at the top and then went down, that would be decreasing because starting up here, it comes down. So when you're looking at the graph, you always start on the left and you read it like you do a book. Okay? You never start on the right and then try to figure out what's going on. You always start on the left. Okay? And that'll make sense when we look at the parabolas because part of it is increasing and part of it is decreasing. And so that you figure it out by starting on the left. So that's what that means. Any questions about all the words? There's some more words that I'll show you when we get to a problem, but we'll do some more when we get there. Here's just a random graph. It's a parabola. How do I know it's a parabola? Because it has a U shape. If it looks like a U, it's a parabola. Okay, the first thing I need to know, and you guys already know how to do this, is I want to know what the zeros are. So if I look at it, can you tell me what the zeros are? 0 and 4. I already know that. Okay, next I want to find the vertex. And you may remember the vertex from Math 1. The vertex is the point that's at the very top or the point that's at the very bottom. Okay, so in this case, the vertex is way down here. And what would that point be? 2, -3. It's a point, it's an x and a y value. Okay, questions? Okay, next is something different that you may or may not have seen from Math 1. Okay, it's an important equation, and it's y equals a times x minus h squared plus k. Okay, that equation is kind of a strange equation, okay, but that's the equation that we're going to use. Anytime you see vertex form, this is the equation that we need to know. And what we do is we take the vertex, whatever the vertex is, and you put it in the place of h and k. Okay? The a has to do with how wide or how narrow the graph is. On all of these graphs that I have for you today, the how wide is just going to be a 1, but the how wide will change eventually. And I'll show you how to do that when it matters. But for today, and looking at the graphs that you're going to be looking at, A is going to be 1. Okay? So, you're going to have y equals, and you're going to put a 1 where the A goes. You leave alone the x. Alright, the h is the first value here. So h is 2. And then the k is the second value of the vertex. So the k is negative 3. So in order to write it in vertex form, you have to be able to just plug in that vertex. If you don't know the vertex, you can't do vertex form. Okay? So that's an important thing to memorize. You need to memorize that equation right there. Okay? Any questions? Next, the question is going to ask you whether the graph has a max or a min. So looking at this graph, you're just trying to indicate to me whether there's a min or a max. Okay? So a parabola that's upside down like that, it has a max because there's a point at the top that's higher than all the other points. Okay? If there's a mountain, there's a max. If it's in the valley, it's at the very bottom, and so that's a min. Okay? So the vertex is a max when it's at the top of a mountain, which makes sense because that's the highest you can get when you're on the top of a mountain. And then when you're in a valley, that's the lowest you can get, so that's the minimum. Okay? So in this case, in this picture that we're looking at, is it a maximum or a minimum? Minimum. Okay? Okay, next, it's going to ask me about the line of symmetry. Alright, the line of symmetry is the line that goes down the middle of it. It's the line that divides the parabola in half. Okay? The line of symmetry will always go through the vertex, and it'll be up and down, and it'll go through the x value of the vertex. So if I draw the line that goes down the middle of it, I'm going to draw that line right there. Do you agree? Does that separate it in half? Okay, so what x value does that line touch? X equals 2. We'll look at the vertex. What was the x value in the vertex? 2. The vertex x value and the line of symmetry x value will always be the same. Okay? So for line of symmetry, we say x equals 2. You say x equals because x equals 2 is a line that goes up and down. Question so far? Okay? Y-intercept is something else that might ask you. Well, we've talked about the x-intercepts quite a bit. The x-intercept is where it crosses the x-axis. But where does it cross the y-axis? At 0. It's just the place where it crosses the y-axis. It's right there. With a parabola, it'll only cross one time for the y-axis, but at x-axis might cross more than once. So you can say y equals 0, or you can just say 0. Okay, so then it's going to ask you questions about increasing and decreasing, and then domain and range. So I'm going to abbreviate and put I and C for increasing and DEC for decreasing. Okay? So if you're looking at this parabola and you read it like a book and you start on the very left, is it increasing or decreasing at first? Decreasing. Do you agree? Because it's coming down. Starting way up there and it's coming down. And then it starts increasing there at the vertex, right? Because at the vertex is where it changes and starts going up. So this graph decreases and then increases. So the x value that we've already talked about, that where the line of symmetry was at 2, okay, it increases after 2 and decreases before 2. Do you agree? Okay, so here's what we write. For decreasing, since decreasing is first, we write x is less than 2. And for increasing, we write x is greater than 2. Because again, we're thinking about that line of symmetry. And that's at 2. Well, less than 2 is the left. That's decreasing. Greater than 2 is that side, and that's increasing. Does that make sense? Okay, last confusing thing. Domain and range. And I'm going to put it up here at the top. It's because I'm running out of room at the bottom. The domain on a parabola that looks like an up and down parabola will always be all real numbers. I'm running out of room. I'm sorry I'm squeezing this in. It's all real numbers. The reason is because this graph keeps going left and keeps going right. It never stops. There's no breaks or holes or anything strange in between the graph, but it always keeps going left and right. So the domain is always all reals. The range, however, is not. The range, you see where we drew that line up and down for the line of symmetry? Well, if I draw a line going across, the range is the part that's either above the line or below the line. So does this graph, is it above that line or below that line? Above? Right? Because here's the line and the graph is above it. So here, what we do for the range is we say, what value does that line go through? What y value does that line go through? -3. So what we do is we say that the range is y is greater than or equal to -3. Okay, for the zeros. Caleb, what are the zeros on number 1A? Okay. And then what's the vertex, Logan?
1, -4.
Okay. And then vertex form, Macy?
Y equals 1, and then x minus 1, and then it's 2 minus 4.
Good. Sophia, is it a max or a min? Good. Raven, what's the line of symmetry?
X equals 1.
Good. Garrett, what's the y-intercept? It's actually -3 because it's where it crosses the y-axis, and so it's crosses y-axis at -3. All right, let's do increasing and decreasing together. So increasing and decreasing, it's like you draw that line that goes down the middle. Is it decreasing or increasing first? Decreasing. It's going down and then it's going up. So it's decreasing and then increasing. So for increasing and decreasing, I know it's x, and I know that line that goes down the middle of it is 1. And because decreasing is first, that's the less part. So then I go to decreasing and put less, and I go to increasing and put greater. Okay? It's like the sides of that line is how you think about it. Okay? The domain for these parabolas is always the same. It's all real numbers. And then the range is where you draw the line like above or below it. That tells you where to start. So I know I'm going to start with a y and a 4. -4, sorry. Is the parabola above the line or below the line? Above, so it's greater than or equal to. The zeros on this one, Haley, what'd you get for the zeros? 1 and 3, good. Jennifer, what's the vertex?
2 and 1.
Good. Dakota, what did you get for vertex form? Okay, so it's a 1 at first, and then x. Did you say -2 squared? In the parentheses, change that sign. But then the 1 just goes on the outside. Okay? Haley, was it a max or a min?
Max.
Good. Nate, what's the line of symmetry? Good. X equals 2. Because it goes through x at 2. Lakin, what's the y-intercept? Good. And then, Josh, increasing decreasing. Do you know those?
Huh.
Do you know them? Okay.
X is greater than 2.
I think you got it backwards. Okay, so let's talk about it. It's increasing first and then decreasing because it's coming up and then going down. And the 2 was right because 2 is where it changes. But because it increases first, it's less than 2, and then decreasing is greater than 2.
Alright.
I think you had it backwards. All right, domain is always the same. So Luke, what's the domain?
All real numbers.
Yes. And Taylor, what do you think the range is?
Y is less than or equal to 1.
Good. Y is less than or equal to 1. Because if I draw that line there at 1, and the graph is below that, so less than or equal to. So as you do these, it's not very clear where the x and y axis are. We'll do the x-axis here on that one. And then I think you can see the y-axis, but if you want to make it darker, it's there. And then on the second one, the x-axis, there is a little arrow there indicating where it is. And then there's a y-axis. The interesting thing on these two, if you think about the zeros, like the first two that you did, the zeros, there were 2 of them. But on the number 3, there's not any zeros, and that's okay. And number 4, there's 1 0, and that's okay. So whenever you have parabolas and zeros, it's either going to be 2 or 1 or 0 solutions depending on the way the graph looks.